6.5 notes, essential question. How do you know how to move horizontally and vertically just by looking at the equation of a square root or cube root function? Okay. We're going to be graphing square root and cube root functions, and how you move horizontally and vertically for any function, whether it's quadratic or anything, have the same rules as all functions have the same rules as far as moving horizontally and vertically. So move on to the next slide. Parent functions for square root and cube root functions. The parent function for the family of square root functions is f of x equals the absolute value of x. So you see, if you plug in x or 0 in for x, the absolute value of 0 is 0. The absolute value of 1 is 1. If you keep going, the absolute value of 4, 1, 2, 3, 4 is 2. You should cross at 2. Okay. The domain and range. The domain is x is greater than or equal to 0 because you see x is your smallest 0, and then it gets bigger from there. So every x is 0 or bigger, and then your y is greater than or equal to 0 because your smallest y is 0, and then every y from there gets bigger. Okay. Parent function for the family of cube root functions is the cube root of x. They have some dots here, like the cube root of 0 is 0, the cube root of 1 is 1, the cube root of -1 is -1. And the domain and range for all domain and range is all real numbers for cube root, because you can take the cube root of a positive or a negative number. It doesn't matter. Okay, but you can't take the cube root of a square root of a negative number, and that's why it has constraints and restrictions. Okay, graph the function, state the domain and range, compare it to its parent function. So what we're going to do is make a table. Okay, and the table I like to make for square root functions is this. I like to pick perfect squares for my x. So for example, I pick 0 for x.
Hopefully you completed that. If not.
Okay, so like I was saying, pick 0 for x. So square root of x is 0. 0 times 1/2 is 0, so that'd be 0, 0. Then I pick 1 because that's a perfect square. Square root of 1 is 1. 1 times 1/2 is 1/2. Okay, and then I would pick 4. Okay, because 4 is a perfect square. Square root of 4 is 2. 2 times 1/2 is 1. And let's pick one more. Let's pick 9 because that's a perfect square. So 9. Square root of 9 is 3. 3 times 1/2 is 1.5 or 1.5. I'm just going to put 1.5. So I'm going to graph that 0, 0, 1 and 1/2, 4 and 1, and 9 and 1.5. So you can see that okay, so you can see from there how it grows very slowly. Okay. Okay, and it's not a straight line, it's a curved line, but it's really hard to see that curve because of how slowly it grows. The domain for this, I'll just write D for domain, is x is greater than or equal to 0. 0. The range is y is greater than or equal to 0. So the domain and range didn't change because still 0 is your smallest number, and for x and y, and it gets bigger from there. Okay, and then it says compared to the parent function. The only difference between the parent function and the original is that 1/2. And what that 1/2 does is it makes it shrink vertically. Because if you don't have that 1/2 there, then you just have the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So all the y's would be bigger. But because you multiply all the y's by 1/2, it makes it vertically smaller. So when you compare it to the parent function, you would say it has a vertical shrink, which I spelled wrong. Also say, or you can say vertical compression. Either one works. Okay. So we graphed the function, we stated the domain and range, and we compared the parent function. It's a vertical shrink or compression compared to the parent function. Okay, so it says graph the function. We got -3, y equals -3 cube root of x. The first thing we do is make a table. Okay. And right here, what I would do is put 0 in the middle. Okay. And I'm going to put -1 and 1. Okay. And I'm going to pick -8 and +8. The reason I picked those is because those are all perfect cubes. And so I won't have any decimals, and then I'll make my, graph so I can just graph integers. Okay. So then I plug that in. Well, let me clear this out. This is messy. Got -1. Okay. So we got the cube root of -8, which is -2, and then -2 times -3 is +6. Okay. We got the cube root of -1, which is -1. -1 times -3 is +3. Cube root of 0 is 0. 0 times -3 is 0. Cube root of 1 is 1. Cube root of 1 times -3 is -3. And the cube root of 8 is 2. 2 times -3 is -6. Okay, so we have a table so we can graph it. So we got -8, 6, -9, or 10, 9, 8, 6. Okay, and then we got -1, 3, 0, 0, 1, -3, and we have 8 and -6. Okay, so I'll try and draw this the best I can. Should be about more of a curve right here. Okay, not great, but close enough. Okay, so domain and range. Remember, for any cube root function, you can take the cube root of a negative, and you can see on the graph there's no ending point, there's no vertex to this. So state the domain and range. Domain and range all real numbers. Okay, and then when you compare the parent function, what that negative does right there is it makes it flip. Okay, it made everything the opposite. So the negative, what it does is it reflects across the x-axis. So you'd write reflects across x-axis. And then the 3, what it does is it makes it stretch. It makes your y's bigger when you multiply everything by 3. So when it was 1/2, when it was a fraction, when it was less than 1, it makes it a vertical shrink, like the last example. But this one's 3, so it makes everything bigger. So you write a vertical stretch. Okay. So we graph the function, we state domain and range, all real numbers for any cube root function, because you can take cube root of negative. And we compare it to the parent function, it reflects across the x-axis and in a vertical stretch. Okay. Translations of radical functions. The graphs of radical functions to graph y equals a. This is just a form of a square root function a, square root of x minus h plus k, or y equals a, cube root of x minus h plus k. Follow these steps. Sketch the graph of a, square root of x, or y equals a, cube root of x. Translate the graph horizontally h or k units. Okay. So basically what x minus h, if you have x minus, the number moves to the right, x plus, the number moves to the left as long as it's underneath the radical. It's like parentheses. And then the plus k, if it's plus a number, it's going to move it up. If it's minus a number, it's going to move it down. Okay, so it says graph the function, state the domain and range, compare the function to its parent function. So we're going to graph the function. How we graph this function is I want to start with the vertex of what makes that go to 0. Is going to be my middle number. So my middle number, what makes x plus 4 go to 0, what I plug in for x would be -4, because -4 plus 4 is 0. So I'd plug in -4 first. -4 plus 4 is 0. Cube root is 0. 0, 0 minus 1 is -1. So -4, -1 is going to be my first point. Okay. And then I'm going to pick some numbers around that make perfect cubes. Okay, so, oops, we can cover that. -3, no, I can't. And -5. Because I know that those numbers surrounding, like -3 plus 4 is going to be 1. 1's a perfect cube. So -3 plus 4 is 1. Cube root of 1 is 1. 1 minus 1 is 0. Okay. And then -5 plus 4 is -1. Cube root of -1 is -1. And -1 minus 1 is -2. Okay. So that will surround those points. Okay. So I have -3, 0. And -5, -2. And then I have 3, 0. Okay, so let's say I want to pick some other ones. I want to make 8. Okay, so what plus, because I know 8's a perfect cube, so what plus 4 equals 8? Well, 4. So I'm going to make 4 right here, because 4 plus 4 is 8. Cube root of 8 is 2. 2 minus 1 is 1. So I could graph 4, 1. 1, 2, 3, 4, 1. And then I need to pick another number. What's going to make -8? Well, that's going to be -12, and that's going to be off the graph, so we're not even going to worry about that. But if I did do -12, -12 plus 4 is -8, cube root of -8 is -2, -2 minus 1 would be -3. But that's going to be off the graph, so we're going to worry about that. So we're just graph it based off this, so let me get another. Okay. Not perfect, but you get the picture. Okay. Hopefully you can graph and do this better. I'm not very good at this in the right tablet. Okay, so domain and range. What's domain and range? Well, it's cube root. Take cube root of anything. So domain and range is all real numbers. Okay, all real numbers. I'm not going to write domain and range again. I'll just circle this with this. Okay, domain and range is all real numbers. Okay, and then compared to the parent function, well, that x plus 4, what that x plus 4 does, if you notice the original origin, the original parent function started at 0, 0. When you do x plus 4, now our original origin point starts at -4. Okay, so what the x plus 4 does is moves it left 4 units. And then the -1, it used to start it here, but now it moved down. Now our middle point is, because this is our vertex where everything starts from. So it was at 0, now it moved down to -4, 1. So it moved left 4. That's what the x plus 4 did to it. Okay, and then down 1. And that's what the -1 did to it. Okay, so we grabbed the function, we stated the domain and range. Domain and range is all real numbers, and we compared it to the parent function, went left 4, down 1, because x plus 4 moves it left 4, and -1 moves it down 1. Okay, grab the function, state domain, compare the function to its parent function. Okay, it's the same thing. So we're going to find our middle or our vertex of this one, which is we got square root functions now. So we're going to ask ourselves, what -3 makes 0? Well, 3 minus 3 makes 0. So I'm going to put 3 minus 3 in there, which is 0. Square root of 0 is 0. Times by -2, that's 0, but you get to add 2 at the end, so it becomes 3, 2. Okay. Now I'm going to pick something else that makes a perfect square, which is 4, because 4 minus 3 is 1. Square root of 1 is 1. 1 times -2 is -2, and -2 plus 2 is 0. So we got 3, 2, 4, 0. And what -3 makes 4? Because I know 4 is a perfect square. Well, 7 minus 3 makes 4. So I'm going to do 7 minus 3, which is 4. Square root of 4 is 2. 2 times -2 is -4. And -4 plus 2 is -2. Okay, so that's 3 points that you need. Okay, so we have 3, 2, 4, 0, and 7, -2. Okay, so the graph's going to look something like that. Okay, stated domain and range. Well, square root has restrictions. So in this one, x is your smallest. Okay, so state domain and range. X is our smallest x, and then 3 is our smallest x, and it gets bigger from there. So domain is going to be x is greater than or equal to 3, because that's our smallest x. It gets bigger from there. Our range is going to be notice how it starts at 2 and then it gets smaller, and how the graph is going down. So it'll be less than or equal to 2. Okay. And then compare the parent function. So what the negative does, there's a lot of comparing on this one. You got the negative, which reflects it across the x-axis. That's what the negative on the 2 does. Okay, then the 2, what the 2 does, it makes it multiply by 2, makes it a vertical stretch. If you want to put by 2, you can. Okay, because that's how much is vertical stretch, whatever that number is. Then the x minus 3, what the x minus 3 does, moves it right 3. Okay, and then what the plus 2 does, it moves it up 2. So that's a lot of comparing, okay? The negative reflects it, the 2 vertically stretches, the x minus 3 underneath the radical moves it right 3, and the plus 2 moves it up 2. Okay? That's all the transformations from the parent function. Okay, so exit slip, describe the translation of the given function for the parent. Describe translation of the given function from the parent function. Okay, so do this on your own and go back and answer that essential question. You know, how do you know how to move horizontally and vertically just by looking at the equation of a square root or cube root function? You should know how to do this now. So go back and answer that question and email me if you have any questions, or ask questions next time in class.